also going to share my screen with you. I hope that you have something to write on, my darlings, or write with. Okay, let me move this down the bottom. Okay, start our presentation. All right, so let me go back. All right, so for anybody who has not enrolled in the class yet, the enrollment code is on the screen, BE6163FB. You can just write it down on your paper and make sure that you enroll over the weekend, because I think Monday we are going to do our first assignment from Summit. Because remember, next week we only have 2.5 days of school. So I will only see you on Monday. Okay? So again, over the weekend, make sure that you are enrolled in the class. So we are still working on the groundwork. And again, the objective is to assess the prior understanding of students on the concepts that we're going to use in this unit. So we just had our community meeting. We are then going to do our warm-up. We're going to answer those questions, classifying questions that we ended with on Monday. On Tuesday, thank you. On Tuesday. And then we're going to do a quick review, and then we're going to start the next piece of our groundwork. And we are going to talk about the shape of distributions. All right, so here we are. So on Tuesday, we ended talking about quantitative and categorical data. And, excuse me, can anybody remember what is quantitative data?
Hold up.
You like measure.
Yes, quantitative data. It can be measured, because remember, in that word quantitative, we see what good math word?
Quantity.
Yes, quantity. And of the things that we can count, they are either discrete, you use whole numbers, or continuous. It can be parts. So again, discrete, you can count. There are no pieces. Continuous, you can break it up like your height. Okay? Or the data is categorical, and categorical data is divided how? What word is in categorical that we know?
Category.
Yep. And categories are what? What's a simple word for category?
Separated, categorized.
Or grouped, right?
Yeah.
So categorical data is grouped, and it is either nominal, that means it's a description, or ordinal. And ordinal means that it has a range. So we are going to classify these 7 statements. So, so the first one. Oh my, you about to call up a lawyer. You silence yourself. Get that together, boo.
My fault.
All right, the first one. How do you rate the dessert served tonight? Is it discrete, continuous, nominal, or ordinal? And if you must, think about what type of data it is first, quantitative or categorical, and then
Quantitative.
we can count it. Remember, quantitative data, we count. Categorical data, we can group. So do we group it or count it?
Group it.
Yep. So it's categorical. So now, does it have a scale or does it describe something when you're rating? Is it a scale or a description? Or do you use a scale or is it a description?
Is it a description?
Yeah. Scale.
It's a scale because it's either good, bad, okay, right?
Mm-hmm.
Okay, so the first one
Oh,
should be, right, it's categorical, but it's ordinal because it has a scale. It's either good, okay, right? When you talk about the dessert. All right, now look at number 2, the height of each person in the class. Again, can we count it or do we group it? Does our answer come out in numbers or in words?
Number.
Numbers. So that means it has to be quantitative. So is it all whole numbers or can it be broken into parts? Discrete whole numbers, continuous parts. Which would it be? Think about your height. Is your height a whole number or is your height broken into parts?
Broken
It's
into
broken
parts.
into parts.
Broken into parts. So it's continuous. Number 2. It is quantitative because the answer can be measured, but it can be in parts. We are 5'7". We are 5'6", 4'3". Okay? Yep. So number 3, what is your proficiency level in PowerPoint? So can it be measured or do you group it?
Quantitative.
Now see, all right, if it's quantitative, what would it be? Would you say it's discrete or continuous?
Continuous.
Why continuous? I'm just asking.
Because
Well,
quantitative data can be measured, right?
Yep, quantitative, it can be measured. Discrete means whole numbers, 1, 2, 3, 4, 5. Or continuous, 1.5, 3.7.
So proficiency can go by that, right?
So, okay, so if you want to go quantitative, you know how, what does it say? 1 being good, 2 being, or would we be categorizing? These people are excellent. These people need work.
All right. So it's
What you think?
categorical.
Categorical would be better. You could figure out an argument for quantitative, but categorical would be better. Now, again, is it descriptive or does it have a range? Because if it's descriptive, it's nominal. But if it has a range, good, bad, 1, 2, 3, 4, 5, it will be ordinal. So what you think?
Ordinal.
Yep, ordinal. So it is categorical because after you answer that question, you can put people in groups. And it is ordinal because you have proficient, then you have know a lot. You know how you had those things. Know a lot, but not everything. Could be better. Those kind of things. Okay, number 4. Would it be, in which age group do you fall? So, again, Quantitative or categorical? Are we measuring it or are we grouping them?
Grouping.
So we are categorical. And now, is it nominal or is it ordinal? Is
Ordinal.
it's a range or is it descriptive? Would we be describing something or will we be looking at it on a scale, rating something?
Descriptive.
Yep, you're going to be grouping them. So it should be nominal. Okay? Because you have 1 to 5, then you have 6 to 8, then you have 9 to 12. You know what I mean? So you would be grouping them. So that's categorical. And again, it is nominal. You are grouping them by a specific criteria. All right, number 5. What is probability? The probability that will rain on Thursday. Quantitative or categorical? Can it be measured?
Quantitative.
Yes. So is quantitative, is it discrete, whole numbers, or is it continuous? Can be broken up.
Continuous.
Continuous, yes. They tell you it's a 65% chance, a 72% chance. So yes, number 5 is quantitative and it is continuous. Number 6, males in first period math. Measuring it or grouping it?
Categorical.
Got a question. All right, so we group it, but we already grouped them because we asked for males. So that is the group. So are we counting them or are we, oh, well, they are already grouped. So we have to be counting, right? So
It'd be quantitative.
yes. Now, would it be discrete or continuous? Whole numbers or can be broken into parts?
Continuous.
We can break a man into parts. So we can have 5.5 men in first period. Remember, discrete means that we count it by whole numbers. Continuous means that it can like have fractional pieces. So males in first period, yes, it is quantitative, but it has to be discrete because we can't have a quarter of a person. We either have 5, 7, 12, 13, discrete. Okay, so males in first period, it is quantitative and discrete. And then the last one, what are your motives for traveling? So, categorical or quantitative? Are we grouping them or counting them?
Counting.
They're asking you why you traveling. Remember, they say when you go somewhere, they say, "Why are you traveling?" Pleasure. It's categorical, right? Because the answers would be things like family, pleasure, education, business. So, yep, it's categorical. You would group them. And is it nominal, meaning descriptive, or is it ordinal, on a scale?
Wouldn't it be nominal?
It will be nominal, yes, because you're grouping them together. These people are traveling for business. These people are traveling for pleasure. These people are traveling for a family function. Okay, so for those people, and for number 3, I was seeing if somebody had an argument for it being ordinal. So it could have been, for me, 3 could have went either way. Okay, so again, we're going to be looking at this categorizing the data so that you can maybe make better decisions about what kind of graphs we should use. So again, we laying the groundwork for what we're going to do. So in a review, the measures of central tendency, again, we usually think of them individually, the mean, the mode, and the median. But collectively, they are called measures of central tendency, and it is a single value used to describe the central point of data. So I just threw that graph there. Okay, so here is our distribution. This is how the data graphed. And then they show the red line is the mode, the green line is the median, and the blue line is the mean. But we're going to discuss that when we talk about types of distributions.
Are we writing this down?
No, you don't have to do this should have come from Tuesday. This is just a review for people who may have missed it. So the mean, the mode, and the median, if we use regular terms, it's the average, what appears the most, and the middle. And then, although it is not a measure of central tendency, it relates to the spread. And the spread is just that. How much space is between the first number and the last number of a term of our data? So we find the range, and the range gives us that. The range is the difference between the highest term and the lowest term. And then we talked about data types. So categorical data is information that can be divided into groups. You have nominal data, which is descriptive, like your school grade, 9th grade, 10th grade, 3rd grade, 5th grade, kindergarten. Or ordinal, it has a set order. And it's like the pain scale in the doctor's office. You know, they give you that little card and ask you, rate your pain today. And it goes from 0 to no pain at all to 10, and the face is like all crunched up. And we have quantitative data. We have, thank you. We have quantitative data, and that's information that can be measured. So it can be discrete and it can be counted with whole numbers only. Remember, whole numbers only. That's discrete. Or it can be continuous. It can be broken down into pieces like your shoe size. You might, instead of wearing a 5, you wear 5.5. You know, instead of wearing a 8, you wear 8.5. Okay? So those are the things that we talked about. So now, with all of that, we now are going to talk about distributions. So, and a distribution is merely a graph of data, and depending on the shape of the graph, you will be able to determine certain information. So, a symmetric distribution is also bell-shaped. And sometimes you will hear them say a bell-shaped curve. So a bell-shaped curve is symmetric. And in there, we see the word symmetry. Anybody remember what symmetry is? Okay. When something is symmetric, if we use alphabets, capital A is symmetric vertically. Capital B is symmetric horizontally. C is symmetric horizontally. D horizontal. E horizontal. F is not. G is not. H is symmetric horizontally and vertically. And that just means we can cut it in half and the left side looks like the right side. anything that is symmetric. Okay, a circle is symmetric. If we cut it down the middle, we can fold it.
Oh,
We cut it
so
across, we can fold
if
it.
you, like cut it
Yeah.
like half or something, it's like going to be even.
Yes, like remember back in elementary school when you made a heart, your teacher told you fold the paper in half.
And then, like,
If
cut
you
it
only cut out one half,
Yeah.
you cut out one side, but when you opened it, both sides look the same. So
Okay,
that is
makes sense.
symmetry.
Okay.
So in some of our data may come out in a symmetric distribution. Again, it looks like a bell. And one half of the data on one side and half of the data on the other. If it is symmetric, you can split it in half. And if the distribution is symmetric, that means the mean, the mode, and the median are the same.
Miss Hicks, I'll be right back.
Okay. So now, this is something you add to your notes. Okay, so the title, again, shape of distributions. The first one is symmetric. It looks like a bell. Half of the data is on one side and half on the other side. And in this instance, the mean, the mode, and the median are the same. They are equal. All right, we got 7 minutes, so we did pretty good. Okay, everybody has symmetric?
Hold on, I'm still running. Hold on.
Oh, okay. Just let me know. I did.
All right.
Okay. All right. So now, if it is not symmetric, meaning both sides are even, we have, no, why? Oh. Okay, so, oh man, I'm sorry. Let me exit this for a second. I didn't take something out of the slide. Which cousin? Jada? Oh. Tell her I said happy birthday, Peach. How you just? Oh, come on. I'm sorry, y'all. See, that's what happens when you cheat and you just reproduce the slide. You forget to take some stuff out. Okay, so data can be skewed right. So that means that on the right side, there is a tail, and the majority of the data is on the left side of the graph. So when it's skewed right, the tail is on the right side. The majority of the data is on the left side. And we see that in this instance, the mode would be the best measure of center. So see, that's why we talked about the mean, the mode, and the median initially. So if it is symmetric, you can use the mean, the mode, or the median to describe what is the center of the data. But if it's skewed right, see where the mean is? The mean is all the way flush to the right. So the mean cannot, in this instance, be used to describe the center of the data. The center of the data in this instance will be the mode. So here, the mode is greater than the median, and the median is greater than the mean. Okay? So if a graph is right skewed and they ask, what is the best measure of center? It would be the mode. The mode shows where the middle of the data is. Okay? And that's why you need to be able to compute all of them. See how this whole thing coming together? Okay? And let me add something to this slide too. Okay? So again, in your notes, remember, if the data is skewed right, the mode is the best measure of center. And I'll add that too, just in case, for people who have to watch this. Okay. All right, so is everybody good on this one? Because we just have one more, of course, skewed left. I can move to the next slide. Okay. Okay. Okay, oops, see, again, cheating. So again, if it is skewed left, the tail is on the left. That means most of the data is on the right. And here again, and I'm just looking at the graph from left to right. Once again, the mean is the lowest and the mode is the highest. So in this instance also, mode is the best measure of center. So we would think because the mean is the average, that the mean is always, always, always the best measure of what is the center of the data. But only if the distribution is symmetric would mean you could use any of the three measures. But if it is left skewed or right skewed, the mode is the best measure of center. All right, that took us to our almost, we got a minute to spare. So we will start with talking about distributions on Tuesday. And again, remember, I will only have you, I did say Monday earlier, but I will only have you one day next week because Wednesday is a half day and Thursday and Friday is Thanksgiving and Black Friday. So we don't have school. So with that, you all have a wonderful, thank you for coming. On attendance, I have Salam, Aaron, G, Shirley, Man, Quay, and Ralisha. Anybody else? Okay. Thank you, my darlings, for coming. Like I said, have a great weekend. I appreciate you all.
Okay, have a good weekend, Hicks.